In this example, I'm going to use this function g of x, and I'm going to evaluate it at 4 different x values. And we're also going to use synthetic division and show that the remainder theorem, and that's when I evaluate the function at these values of x, is going to give me the same value as using synthetic division and then checking out its remainder. Okay, so let's go ahead and get started with this first one, g at -1. So g at -1 is going to be 8 times -1 to the 4th minus 4 times -1 squared plus 3. And of course, -1 to the 4th is just +1. So 8 times 1 is 8. -1 squared is just +1. So -4 times +1. And then plus 3. And it looks like that should give me 7. Okay, similarly, whenever I use synthetic division on this, okay, so the synthetic division concerns itself with the coefficients. So I've used 8 for the x to the 4th term. There is no x cubed term, so I'll put a 0 in its place. The quadratic term here is -4. There is no linear term, so I'll put 0 in its place, and then the +3. And I'll put my box right here. This guy right here is my remainder. And the expectation is that when I plug -1 into the function, whatever value I get here should be the same as this remainder here. Okay, so let's go ahead and work this synthetic division using the -1. So this 8 will come down, and then multiply gives me -8, adding -8. This multiplication gives me +8, adding gives me 4. The multiplication gives me -4, adding gives me -4. Multiplying is +4, and adding then is 7. So I see that I do get 7 in both cases. So that's the first value that I'm going to use for my g function. Let's go ahead and repeat the same thing for 3 more values, -3, -1/2, and +1/2. All right, so g at -3, well, we're going to use that same function, so 8 times -3 to the 4th minus 4 times -3 squared, and then plus 3 on the end. So this will be 8 times, looks like 81 right there, minus 4 times 9, and then plus 3. Let's see, 81 times 8 should be 648 minus 36 plus 3 should give me, looks like 615. Okay, and similarly, when I use synthetic division on this, so I have 8, 0, -4, 0, and 3. And I'll put my box for my remainder right there. That should be for my remainder. So let's go ahead and work this same process. The 8 comes down. Multiplying gives me -24, adding. Multiplying gives me 72, which gives me 68 here. Multiplying should give me -204. And then multiplying should give me like 612, and then 615 for my addition. And once again, 615 and 615 are the same. Okay, so another line. Let's go ahead and do g at -1/2. So that'll be 8 times -1/2 to the 4th minus 4 times -1/2 squared plus 3. So -1/2 to the 4th will be 1/16. So 8 times 1/16 will be, well, 1/2, 8/16. And then -1/2 squared is 1/4. The -4 times the 1/4 gives me -1. And then plus that 3 on the end. Looks like 2.5, or we can call it 5/2 for this value when I evaluate there. And let's go ahead and run the -1/2 through using my synthetic division and just show that they're the same values. So I'll put my box for my remainder right there. And when I come down, this 8 times -1/2 is -4. Adding gives me -4. Multiplying gives me +2. Adding gives me -2. Multiplying gives me +1. Adding is 1. Multiplying is -1/2. So 2.5 or 5/2, and again, you'll see those values are the same. And so there's one thing I want to say real quick about this function and these values particularly that we're looking for. So we just did -1/2, and then we have +1/2. I wonder what this relationship is given this function. Notice this function is actually an even function. All the powers of x are even exponents, so x to the 4th, x squared, and then my constant. So no matter if I plug a negative or a positive in, I'll get the same values because this even exponent will create a positive value no matter if I plug in a negative or a positive. So evaluating g at negative 1/2 gave me 5/2. Evaluating it at positive 1/2 will also give me 5/2. And when I worked in synthetic division then, I can notice that as well. So let's just do the synthetic division with positive 1/2. So 8, 0, negative 4, 0, and 3. And here's my remainder, which we're anticipating once again of 5/2. So let's go ahead and bring that down. That makes 4 and 2 and negative 1. And negative 1/2 does give me the 5/2. So there's that example. Given the function g of x as this polynomial, and then evaluating that polynomial function at 4 different x values, the remainder then, when I use synthetic division, will be the same as that evaluation.